Hello. Sorry. Hello. Good morning. Are you able to hear me? So shall we start the live session for Unit 3 from Unit 3? Uh, I think this particular topic, ML libraries, we have completed for mid one. So I think we can skip this particular topic, ML lib. I think we already gone through this in mid one. So please react in the chat. Shall we start the session? So majorly in second mid, you'll be able to see this particular topic called unsupervised learning. So are you? I think your people are aware that what is unsupervised learning, etc., etc. So it is used when data has no labels, which means unlabeled data. Which, for example, roll number one, RAM, marks code is 20. So such type of data is called labeled data. But if that is not in order, then we call it as unlabeled data. So here the model tries to find the hidden patterns or structure in data. So there is no predefined output. That is what the main thing you need to mention when it comes to exam point of view. So it is mainly used for exploration, grouping, and data compression. So in big data especially, it is implemented using MLlib. So it will be working on the top of Apache Spark MLlib in distributed system. So one thing I can say is that often um, the big data tools or big data is created with unlabeled data sets. So mostly in every big data tool or MLlib, we will be using unsupervised learning only. So I think you are aware of that unsupervised learning. The major techniques are nothing but clustering as well as dimensional reduction. I've been saying in the class the dimensional reduction, which have been mentioned about the principal component analysis that you need to mention uh, uh, in the examination point of view. I've given the same example. You can mention in exam also. So that is compulsory. And you already know clustering. I've been mentioned about K-means clustering in the class. I will be going through that particular notes. In that also you need to mention it is compulsory for everyone to mention clustering. For clustering, if any question comes, you need to mention K-means. For dimensional reduction, you need to write about PVCA. That particular problem also is mandatory. So that is what you need to mention about this particular two concepts. So coming on to the clustering, so clustering is the process of grouping similar data points, which means, for example, if in a messy class, let's say one example here, in a messy class, so we'll be having two genders, for example, let's say girls and boys. They have been sitting in the same benches, they have been sitting politely. But my task is to divide them such that one row will be girls and one row will be boys. So, which means I am grouping the same data points, which means I am grouping the same gender at one row and I am grouping another same gender at another row. So that type of thing is which we call it as clustering. So, which means clustering is a process of grouping similar data points, which means girls one side and boys one side. So the main idea is that data points in the same cluster are more similar to each other, which means in that particular row, girls are there. So girls are similar to they are the gender is similar. So we don't know the categories and we want to discover hidden patterns in clustering. The main things with it we'll be going through. We want to segment data automatically. If you see here, the stars and dot points and circles are collidely been in one data set. Then after clustering, what happened? We'll be divided into three clusters. We have divided this into three clusters: C1, C2, C3, which means stars is going through one cluster. Dot points are going to another cluster, and circles are going to another cluster. So that is what about the clustering. So another thing, another major topic in clustering, we go through the major important technique, which is nothing but k-means clustering. So k-means is nothing but k-means divides the data sets into k clusters. So where k is predefined number, we can define anything. If we define k is equal to 2, then it is two clusters. If we divide k is equal to, if we define k is equal to 3, then it is three cluster. So in such a way, the k is defined, which means that's why we call it as predefined number. So each cluster has a center called a centroid. In this particular k-means clustering, the centroid plays the major role. Okay. So the algorithm assigns each data point to the nearest centroid and updates the centroids iteratively, which means at every point it checks the centroid how far the distance is. If the distance is close, then it will be assigned to one cluster. If the distance is far, then it is assigned to another cluster. So this is the formula. So this is the formula. Don't worry about the formula. I will explain this. Okay. Let us go through one example first. Now, here I have given some points. A is equal to 1 comma 2 and B is equal to 2 comma 3, C is equal to 8 comma 8 and D is equal to 9 comma 9. And I want I have given a predefined K, which means I want to divide it into two clusters. Okay. Then what I have done is nothing but I have calculated the distance. Already you know the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. So which means I need to calculate the distance of every point, which means AB I need to calculate, AC I need to calculate, and even AD I need to calculate. So in such a way, if I calculate, this will be the values I will be getting. Okay. Then after that, after getting that values, I need to find the centroid. The centroid is nothing but 1 plus 2 by 2, which means this is for A, okay, and 2 plus 3 divided by this is for B. And same way for G2 also you calculate 8 plus 8 and 9 plus 8. So, which means if you see here 1 plus 2 and 2 plus 3. You don't only go for A points. So 1 plus 2, 2 plus 3. In the same way, 8 plus 9, 8 plus 9. I have calculated the centroid for this particular things, G1 and G2, and I will be getting 8.5 and 2.5. Okay. If you see here, now what I am doing is nothing but I am calculating the equidistance from the centroid 1.5 minus the data point of A 1 1.5 minus 1 whole square and again 2.5 minus 2 whole square. If I do I'll be getting ended up getting 0.5 and G1 with B with respect to B if I check 1.5 minus 2 and 2.5 minus 3. Then again, I will be getting 0.5, which means I can group these similar data points to one cluster and CD to another cluster. That is how this k-means clustering works. And moving on to another thing is nothing but dimensionality reduction. I think comment section is not audible. Hello, is my audio audible now? Now, hello. I think comments are off. Comments are not able to. Let me see the comment section. Okay. Let me create another broadcast, which means I have given this particular live session for childs. I've been not clicked that particular. No, I think I wanted to disable one option, and I will enable that such that comments will be on. I think in this particular live session, comments are not able to broadcast. So I will join. I will recreate that particular comment session, and let me give you another updated link.